workbench for today, I have a BENQ LCD computer monitor. As you can see, the power light is on. I got no backlights, I got nothing. I got it plugged into my little media player here, which just got a video of my aquarium that I did years ago. It was a little media player I got in an auction for, I think I got this in an auction that I bid $1 on with a bunch of electronics. $1 or $2. One of the things in that auction was worth a lot of money. It was a Sony DVD recorder with an internal, I think it was 160 gig hard drive. Basically a DVR with an internal burner. I got that and a few other things, but this is one of the little things that kind of is useless, but I figured out how to make it work. It actually had a Bose speaker display video on it that was shown in a Costco, because it had a whole Costco commercial, but I figured out the file format that it used and the naming of the file, and basically you load a file of a specific name onto the SD card. It's not even an SD card, it's a compact flash card, and it'll repeat that video over and over and over again. So I figured, okay, what the heck, it's good for display because it's got both a VGA output as well as a composite output, and you can change it with a remote control. And then I just happened to find a remote that will control it and switch modes. But anyway, we got a bad display here. Again, this thing's really not worth fixing, but this is a teaching exercise. This was one that was given to me by a customer at work that just said, can you recycle this for me? I said, sure, I'll recycle it for you. I'll take it home and fix it, and then I'll recycle it. So let's get this thing apart and see what's going on with it. Obviously, it's got power because the power light is on, so it may not be a power supply problem, it may be a backlight problem. So basically, we pop out the screws in the cabinet, and the unit should just pop apart. Most of these monitors, you also have to remove the base because the screws that hold the base on are also holding the cabinet together, so keep that in mind. You got to take the base off on most of these type of panels to be able to open them up. Again, I haven't opened up one of these BENQ units, so it's a learning experience for me here too. And of course, there's always that one hidden screw that has to be removed. And then this whole base should slide out like that, and the unit should open up. So we'll just take a screwdriver and just kind of pop the tabs. It's got little tabs that lock it together. You might want to be a little more gentle than I am if you don't want to mark up your unit. Again, this unit is one that I'm not going to be doing anything with once it's fixed. It's on the small side, it's only a 15-inch monitor, so it's kind of small for a computer monitor like to use. Maybe somebody might have a use for it, but not me. Okay, we got some shielding we got to pull off on the side. And then we can remove the signal board from, or the module with the signal and power supply components in it from the actual display. Now once again, this BENQ monitor, I have no idea what's wrong with it. I've never been into a BENQ monitor before, so this is a learning experience for me too. So observe as I do my troubleshooting and you might learn something. It appears that the front panel is bezels held on by a couple more clips here, so we'll just release these clips and then the bezel should lift off. We're going to need to remove this plug here. This is the front buttons that need to come unplugged. Then we're able to separate the bezel from the unit. The reason we have to do this is because there's some screws along the side here that have to come out in order to separate the backboard. There are some more screws along here that need to come out so that we can access the electronics from the screen. You can see this is a well-shielded machine because it's an older one. The newer monitors don't have nearly this type of shielding that the older ones did. Now there are going to be some wires that connect for the backlights, and they're actually right here underneath this foil. Okay, here are the backlight wires from the ballasts. We're going to just unplug them, and now we're able to lift. Nope, we can't because we have the LDVS cable over here. It's a ribbon connector that is very, very short, so we're just going to lift up the little catch on that so we can unplug this connector. And now we're able to lift the main unit away from the screen itself. Since our backlights aren't lighting up, I'm going to concentrate on this main board here at this point because I think that's where our problem is going to be, and not in the actual panel itself or the T-Con board, which is here, the timing controller. Here's the connectors for the fluorescent lights on the unit for the backlight. And our main power unit is just connected by this sticky shielding grounding tape that we can peel off here so that we can separate the two units. I'm going to put the screen aside so it doesn't get damaged. Now, despite the fact that I have a power light on this, I'm not totally convinced that we don't have a power supply problem on this, because the power light's going to come on if the 5-volt supply is working. This power supply is going to have more than one supply. It's going to have a low voltage supply for the digital circuits, and it's going to have a high voltage supply for the fluorescent backlights, which are plugged in directly to this board here. So, I'm going to pull the board out and we're going to take a look, and first of all, see if we see any bulgy the caps, because bulging capacitors are a dead giveaway that they're bad, and we may just have a capacitor failure on this thing. It may be something more than that, but let's start out with the basic stuff first and see whether it is something as obvious as a cap that the top has been bulged up on or the case is expanded, because that's a dead giveaway that the capacitor itself has failed. Secondary faults, of course, could be high ESR on the capacitors, which haven't resulted in the can bulging. So to get the board out, we've actually got to remove the screws on the signal board as well. Also, the two screws down here that hold the connector in, and there's one more compression fitting down here, a standoff type fitting that we have to squeeze to open it up, and then we can remove both boards, because I believe the two of them, I'm going to cut this thing out of here because I'm lazy. And I hate those connectors. Useless. Now we should be able to lift the whole assembly out. Oh, maybe got one little clip here that I got to take out that's holding the power connector in place. And now the whole thing should just lift right on out like that. The reason why I had to take out this other board is, as you can see, the signal board doesn't unplug this way, it unplugs that way. So these pins were holding, the header was holding the board in place. That's why the signal board had to come out. Okay, what do we look at this thing? I see capacitors here that are bulging right here, these two. And that one. So I'm going to go out on a limb without even testing these things. That one, and that one, that's the problem. Shall we confirm it with the ESR meter? And then I'm going to change just these three capacitors and nothing else, and I bet you that'll fix the problem. So let's get out the ESR tester. We'll turn it on, and zero it out. And then we'll test these 3 capacitors in circuit. So the first thing we want to do is we want to make sure that they are totally discharged. So I'm just going to use my good old pliers here. And we'll make sure that all these capacitors are shorted out. There, they're dead. Okay, ESR for this one, 0.47, that's bad. These capacitors on here are 470 microfarad at 35 volts. And this other, they're all 470 at 35 volts, all 3 of them. A 470 at 35 volts should be no higher than 0.09 according to the chart here on the ESR meter. 0.09 is the limit for a new capacitor, and this one's 0.4, so it's bad. This one here, 0.48, it's bad. And this other bulged one over here, 0.53, it's bad. There are other ones also in parallel with these ones, but these are the ones that are obviously blown. And this one here looks like, yeah, this one's going to be gone too. It's in parallel, and its top is lifting as well. Let's check this other one here out. This one here, the top is not expanded on, and it's, you know, it's coming up at like 0.01, so that one's good. And some of these other ones down here, 0.00. That's pretty darn good. That's close to nothing. 0.2. What's the value of that one? That one is a 16 volt 1000. And it's also measuring a little high, but I'm not going to change that one right now. I'm going to change the ones that I know for sure are bad because I just want to make this thing work. So let me go find some 470 microfarad at 35 volts. That might be a stretch. I don't know that I've got any that are that high in voltage, but let me go look through my scrap bin and see what I can find. You know, people will quite often say, why do you keep all those old circuit boards around? Why do you junk them? You know, when I scrap a TV, for example, I'll take all the boards out and I will keep the boards and scrap the rest of it. And I get people say, well, why don't you just throw the whole set out? Well, the reason for that is a lot of times there are many good components on the boards, especially if it's a screen that's been broken. And I've fixed more than one TV, including TVs that I've fixed for pay. The 40-inch Sony, for example, that's one of my other videos that had the power supply that was blown. That was actually a customer set. And I was able to salvage a couple transistors out of the power supply of another set that had a broken screen to fix that set. To buy those parts from Sony would have been over $50 for the 2 transistors. So I was able to recycle perfectly good parts. And here's another case. These caps are 470 microfarad. They're 50 volt rated instead of 35, which is fine. You can always go a little higher on your voltage rating. You don't want to go lower because, well, the other ones failed for a reason. They were running too close to the limit. So it's okay to go to 50 volts. Not a problem. So I'm going to salvage these capacitors off this board and put them in the other monitor, and that hopefully will be all that is wrong with it, and I can get that little monitor up and running. Again, it's just a project to show you how to fix it. I don't have any need for a 14-inch computer monitor. I've certainly got enough computer monitors lying around here that have been given to me over the years or that I've upgraded. This is just a project, and I'll donate it to someone who needs a monitor once it's done. But this is a teaching project to teach you guys how to fix this stuff. So I'm just waiting for my soldering iron to warm up, and then we'll pull 3 of the caps off of here, get them on that board. So thanks to a couple of old donor sets, an old LCD TV and an old plasma TV, I was able to salvage the required components to put into this unit and see if we can get this one functional at no cost to me. So I'm just removing the old components now, and I'm not even using solder wick or anything. I'm just using to heat the pins and rock the component back and forth because these are through hole parts, so they're pretty easy to take out this way. And got 2 more down here. Now remember, when you're working with electrolytic capacitors, that polarity is important. The boards usually are marked as to what is the positive and negative, but not always. So be sure when you're removing capacitors that you remember which way they went in, so that you know that the new ones are going to go in the same way. In this case, this board is marked. The side that's got the white paint on it is the negative terminal. This came out like that. You can see the rest of them, negative terminal to white. So those are our 4 capacitors that we're going to change. They're the 4 that had the tops that were bulging on them. 2 of them were quite predominantly, the other, well, one of them, actually 3 of them were, but the 4th one is also still bulging. It's not to the same degree as the others, but it's going to get changed out anyway, because we did test the ESR, and the ESR on them was bad for all of them. So now I'm just going to make sure that the holes are open here on the board, so I can just plug the new parts in. I got to open up these ones here. I'll just use my vacuum tool to do this. Starting to get a bit warm out today. I've got the garage door open because it's starting to get just a little bit warm in here, and as you can hear, my central air on my house just kicked in. It's still relatively early in the morning here. It's only like 10 o'clock as I work on this unit. I haven't been making as many repair videos as of late, just because I've been on holidays, so I haven't been around. I have been working on other projects, video projects. I've been shooting a lot of video as I've been traveling around the province of BC and Alberta and the states of Montana, Idaho, and Washington. I've been out and about shooting lots of Ultra HD 4K video and a bunch of time-lapse photos, which I'll be featuring in upcoming videos that I'll be putting together through the off season when I'm bored. And of course we'll be doing some more of the service videos. I've got a bunch planned. Got a bunch more VCR ones planned. We'll tackle some specific faults on VCRs. Mechanical and electrical. Going to do some electrical troubleshooting on some of them. I'll come up with some ideas of things to do and actually plant some faults, some common and some not so common faults, and then we can use signal tracing equipment such as oscilloscopes and stuff to find the problem and fix it. These ones are a little larger in size because they're a little higher in voltage still, but still we're okay with them. It just may be a little more of a challenge to make them fit into the board because the pin spacing is a little bit different, but I'll get them in, no problem. One of the ways to combat a component that may be a little too tall to fit in to an area, like these are a little taller capacitors, is just to lay them down on their side like this and then secure them in place like they've done with the main power filter with some silicone. So I just extended the leads on these 470 capacitors because they're just a little bit taller than the originals. And we're now going to solder them down to the board, and then I will secure them in place with some silicone, and we'll get this unit back together. So we'll just solder the leads on at the bottom here. And do the same for the other 2 capacitors, which are these ones down here. And I'm just going to get some silicone to secure these down, and then we can start to reassemble the unit. Of course, we want to do this so that, first of all, to make sure that they don't short out to anything, but also to make sure that the components stay put once they're installed. So we'll just put a blob of silicone on the bottom of each capacitor, and then just stick it down to the board, and that'll hold it in place so that we don't have to worry about any movement, and we don't have to worry about the leads here shorting out to any other components, just like they've done with the main filter here. So I'm just going to let this cure for a few minutes, and then we'll get to reassembling the unit. Okay, the glue should be set up enough now that I can put this back together without having to worry about it coming apart. We'll just plug the two boards back together like that and set the whole thing back inside the shield cabinet. Replace the screws. Place the clip just to hold the power connector in place. Just a strain relief for that. A couple screws down here for the VGA connector. And now we can reattach the screen. So once again, we have the screen in place. Just put our bracket with our board on it back together, and we'll attach the screws. Now we can apply power and test it out. First we have to reconnect the LDVS and the connectors for the fluorescent lamps. So we're going to flip up the little gate here on the edge connector, slide the edge connector in, and then close the gate down like that. It's called a zero insertion force socket. On the other side here we've got the power connectors for the fluorescent lamps, and we have one more connector that connects on the bottom of the screen, and that's for the bezel. So we just take the display, set it into the bezel, and it should just clip into place just like that. Now we can push this shielding material back down to make the connection and reconnect our connector there. And I'll just connect up my... What was the name of that movie? Where the terrorist was making his demand and on camera, and the battery went dead, and the guy was shaking with the camera and he couldn't hold the camera steady, and the terrorist looks at me, he says, what's with you? And he's holding the camera and he goes, battery is dead. He says, then go and get a new one. What movie was that? Was that one of the Die Hard movies? Anyway, it was one of those action movies from back in the 80s. My battery died, so we got a new battery in here. We'll plug this thing in. Turn it over. Looks like it's fixed. Let's play it off my media player there. Go through some of the modes here on this thing, see what it does. What is burn-in mode? Yeah, there we go. So there you have it. That's a BENQ FP731 dead set. The problem was four capacitors. All 330 microfarad rated at 35 volts. I replaced a couple of them with rated 50 volts. The other ones I replaced were, I think they were 63. They're a little bit bigger anyway. They were taller, so I had to bend them over and put them on their side, but that's all that was wrong with this one. Hope you enjoyed this video, and I hope some of you can make use of this simple fix to save another perfectly good monitor from the landfill. Kind of like these 4x3 monitors. They're good for applications that don't need a wide screen. So sure we'll find a use for this thing, or someone will. And there you have it. Back together, all ready to be put back into service. We'll catch you in the next video.